Many people think of Alinex as their SolidWorks vendor, which we are, but we are also continually evaluating new and emerging technologies and handpicking products that we feel work well to solve specific product development challenges we see some of our customers confronted with. And ExactFlat is a great example of a technology we believe can be a tremendous help to our customers whose products include industrial fabrics or composites, or they're creating organic shapes formed into sheet metal parts. So today's demonstration is intended to give you an understanding of the technology, and just a forewarning that your Alinex sales rep will follow up in the days ahead just to get a little feedback on what you thought of today's presentation and whether or not there's an appropriate next step for you. So with that, I will turn things over to Eaton Donald, the CEO of ExactFlat. Thank you.
Thank you, Al. I just want to make sure that all the panelists and the organizers can hear me. Am I coming through loud and clear?
Yes.
Okay, terrific. Well, I'd like to thank everybody for joining us today. We're going to spend about half an hour or so giving you a high-level introduction to ExactFlat. I'm joined today by our application engineer, Keith McQuan, who is going to be giving a live demo. We're going to have a little bit of a preamble prior to getting into it, and I would encourage anybody to ask any questions along the way. You can just type your questions in the chat box, and we'll pause for a moment during the presentation at various stages to address those questions. So without any further delay, Keith, if you could maybe switch to the next slide, please. So here's why we're here today. I'd just like to point out before we begin that ExactFlat is a gold certified SolidWorks partner, which is the highest level of certification available through the SolidWorks Partner Network. We are an add-in to SolidWorks and have been in market now for just coming up to a year, but prior to that our technology has been available in various standalone applications, so it's fairly mature technology that's been used in a wide variety of customer applications. But what we're here today is we're going to paint a picture on how you can improve your productivity and your workflow. And we make a bold claim that it's up to 90% faster, and when we say 90%, we really do mean 90%. In fact, we have verified clients who are documented case studies where clients are getting where our customers are getting greater than 90% productivity increases, and we'll give you a little sense of how that is. And what we'd like to have you keep in mind is that if you have priority problems or priority questions following this, we would very much like to do a custom demo at your organization, perhaps files that you have, and talk about your workflow and your specific context. But for today's purposes, we're going to talk about going from CAD to Cutter and CAD to Document, which are the two sort of primary aspects. If anyone is interested in going from CAD to Cost, that will be the discussion we can reserve for another day. Keith, if you can switch to the next slide, please. In terms of the agenda, we're going to be covering 5 aspects of the workflow. We're assuming we're starting with a 3D model, but we could actually, in fact, start with a 2D model. We could start with a laser scan. We could start with digitized input. Any supported format that SolidWorks supports could be the starting point for the workflow. And these 5 aspects, creating your initial flat patterns, adding pattern features such as notching, grain lines, seam allowances, things like that, nesting, creating a production export file that would go to your cutter, and then drawings for design reviews, vendor whitelists, cut lists, things like that. Next slide, please, Keith. Oh, actually, if we can just switch to the live demo, please, Keith. So here we have a model which has been created in SolidWorks. This is a model of a car seat. In terms of the modeling process, you could actually model using solid bodies or surface bodies. What we'll be doing is we'll be selecting the faces if it's a solid body, and we'll be selecting the surface bodies if it's a surface model. And what Keith is doing right now is he's selecting individual faces on the surface body to create a pattern piece. So for those of you familiar with SolidWorks, there may be instances where you have modeled a part with many facets on your CAD model, and the challenge is how to go from the CAD model to pattern pieces very quickly and easily. And you can see that we've got this tool here called the Pattern Piece Creator, and you simply select the pieces. If you're working with a layered product, say for example an insulation wrap or a composite product, you can select right through faces. Once they're selected, they become locked for editing, and it's a pretty quick process. So that's the first start of our workflow to get to a flat pattern piece. From here, we're going to go through a convert process, and the convert process is going to create our initial flat patterns, but it's also going to do things like indexing associated seams and edges. The next part of the process is we will add a material. So we're going to assign a material to this model. The material assignment will have a couple of other characteristics. It'll have engineering properties such as Young modulus and the Poisson ratio. Just slow down for a second if you would, Keith, please. Young modulus and Poisson ratio, and information about the actual fabric roll, the grain line, the width of the fabric roll, and so on. So now we go to our flattener view, and you can see that we've got an initial flat pattern there. This is based on a relatively simple algorithm that if you had a developable surface or square, straighter surfaces, like for example in sheet metal, you'd have a perfectly flat pattern at this point. But we're going to go through the process of optimizing it. So for organic shapes, there's a couple of extra steps you have to go through. You can see here we're creating a new mesh for analysis. That mesh is going to help us decrease the solve time and increase the pattern accuracy at the end. So now that we've got a new mesh, you can see there's some color coding there. The color coding is a stress and strain map, and you'll see when Keith hits the optimize button, that stress and strain is going to go away. So go ahead and optimize, Keith. There's about 5 algorithms that are working here in a row, and they are searching for areas of sag or wrinkles, and they're searching for areas of strain and trying to eliminate both. And you can see it does so pretty quickly. It's a multi-threaded application, so if you have more cores, more processors, it's going to go faster. This particular one is not running on a very fast laptop. It's kind of a standard sort of minimum level entry laptop that Keith is running on, and we do this just to make sure that people know that you don't need exceptionally fast hardware. Although if you do have it, it's better. But there you go. There's your initial flat pattern. So let's just click OK. We're going to rebuild our indexes because the pattern perimeters and geometry has changed. And now we go to our pattern view. And we're just going to lay these things out just in a way which is analogous to the way that they're going to be sewn together. But before we do that, we have to tell SolidWorks we have some new geometry, so we just update the pieces. And now we're going to go through the layout process. So in terms of what we talked about before, the first part of our workflow, creating initial flat patterns, that's it. Now if you are using 2D CAD, or if you're building physical prototypes where you have to drape and create your patterns manually, you'll probably see this as a breath of fresh air. You can see here that as Keith selects an edge, it automatically finds a neighboring piece, and he can walk.
Doing well. How are you?
He can walk the pattern along the edge there very easily. So yeah, there we have our first part of our workflow completed. We created our initial set of flat patterns, and we did that in I'm just going to say under 5 minutes. So depending on how long you're taking today, we know that for some companies, if they have to create a flat pattern, like say, for example, in the automotive or seating industry like this may take anywhere from half a day once they have a physical prototype to a couple of weeks to get the patterns correct. So in 5 minutes, we've got the job done, and here is sort of proof point number 1 of our claim that it's really up to 90% faster. The next part of our process is we're going to do some basic pattern engineering here. We won't go through everything associated with pattern engineering. What Keith is doing right now is he's selecting an edge, and you can see when he selects the primary edge, the secondary edge is automatically found and associated with the primary edge. That is a result of having indexed all of our edges through the flattening process, so you don't have to go hunt for edges, you don't have to go hunt for seams, you just have to select an edge and it'll automatically be found for you. And in terms of putting a seam allowance or a notch chain in here, you can see it's very simple. You just select from a list. Here Keith is putting some notches on. We're going to go through this again. We'll go a little bit slower next time around. There's a variety of supported notches, so just go ahead and put this on, Keith, and we'll do another edge and go a little bit slower here. So just from an interface perspective, you can see that the seam tool is at the top. This is 100% embedded within SolidWorks. And as Keith selects an edge, you can see that they automatically find the neighboring edge. And as I mentioned before, that's because we've indexed all these locations through our flattening process. Now what we do is we go down to our property managers, and we have a number of join types. If you just deploy that again, we have a number of seam types. This is completely editable, configurable, whatever standards your organization or your industry uses, you populate your database with those standards, and you can very quickly find the edge you're going to use for your pattern piece, And it's a very good way to enforce standards and minimize the errors associated with putting a mistaken edge on or mistaken seam allowance on an edge. Next, we're going to put notches here. You can see we just click the button to create a notch chain. Again, we have a variety of notch types that are supported. You could edit the geometry here, so if you wanted a deeper V or a wider V or a U or a box notch or a reverse notch, all of that geometry is editable and configurable, so you don't have to sort through a huge list of all the supported notch types. You can actually narrow it down to what is relevant for your organization. So let's click OK there. And what we've done here is we've got two ways of doing this in automated notching. One is specify by count, and the other is specify by spacing. So we can say in this particular situation, put a spacing of 100 millimeters, and it will automatically put the notches 100 millimeters apart. If you wanted to put change the number to say 200 millimeters, it automatically adjusts it. And if we wanted to, for example, say I want 3 notches along this edge, then we just click specify count, and the 3 notches will go along that edge. The changes that you saw Keith making there are the same way that you would edit your notches if you wanted to change them. We have ways of putting manual notches in using SolidWorks sketch entities. We're not going to show that right now. If anybody wants to see us do that, we're happy to do so. But in the interest of giving you a flavor for the workflow, we're just going to forego that aspect for this demonstration. So I think, Keith, that we'll probably stop here with the pattern features. I think we've made the point in terms of how to put features onto your pattern pieces, and we support hems, bound edges, raw edges. You can put markings on there, drill holes, appliques. You can specify grain direction, all of which we can come back to at a later date if you're interested in seeing more. But what we're going to do now is we're going to go to our markers. But just before we do that, this was the second aspect of our workflow. So in about 5 to 10 minutes or so, you could have a project of this complexity with seam allowances, alignment notches, markings, and so on, ready for nesting. And this is the second aspect of where we save time and effort. And again, this is one area where we're confident that the savings are in and around 90%. Okay, Keith, let's go to our marker view. So we have full production nesting within ExactFlat. Here we're going to be nesting on sheets. You could actually have bound surfaces or unbound surfaces, or you can have even irregular size surfaces if you're working with end of rolls or hides or things like that. You can see on the left-hand side where the pattern pieces are listed, there is a little line on each piece. That's the grain direction. What we're working with right now is the default grain direction. When we assigned the material for our flattening process, there was also an assignment for grain direction should this material have a grain. So if you have a particular fabric with an orientation or with a nap or with a pattern, you can easily specify the grain direction using a SolidWorks sketch entity. Now what Keith is going to do is we're just going to go and use the default settings here for nesting. It's very straightforward. As you can see, you click the nest button. The nest can be programmed to run, here it's set to run for a minute. It can be programmed to run overnight. You can batch jobs together. The lay rules you can see there's a two-way lay constraint. The lay rules are editable by piece or by the nest. And the lay rules also were part of the default settings that came in when we assigned the material. So we're going to go ahead and stop this one here. You can see that if we let it run a little bit longer, or if we change some parameters, allow different types of rotations, we can probably pack the nest down a little bit more. But let's just go ahead and stop it and accept it. And let's get this nest ready for export. So we have a number of presets. We've built the product in such a way that you can define presets and define the specific parameters associated with exporting. You can see export to Electra, export to Eastman. We do support the major cutters out there, the ASTM 6673 standard and a number of other standards, but that seems to be the most common sort of industry standard. And you can define what information gets put onto what layer so that the cutter can properly manage those aspects. So let's go ahead and export here. Okay, let's just open this up again. And there you can see our nest on the right-hand side, which is the one we just created. And this is the export file that would actually be sent to the cutter on the left-hand side. And you can see there's some jagged edges there, for example, on the bigger pattern piece. That's because we only put a seam allowance on the top edge, and we didn't continue the seam allowance around. And you can see the notches are represented there. There's piece labels which are represented also. It's really up to how you're going to export your pieces and how your company sorts the pieces in terms of what you want to have in your export file. But that's the export file. This is what you send to your cutter, and in a matter of, say, 15, 20, 25 minutes, you're ready to cut this and build your first prototype or use it for costing or whatever it might be. So that's the nesting and production aspect. And again, what I want to emphasize here is that we've really tried to build the product in such a way that it minimizes the time and effort for all of the normal administrative things that you would have to do historically to bring a product like this into manufacturing. So we started with a SolidWorks model, and in 15 to say 20 minutes or so, we're at the point where we're ready for manufacturing or our first prototype. The other aspect is if you look back at the various things. So if you go back to model view, Keith, so here's our model, the 3D model, and let's go to our flattener view. You can see that our flattener view is now updated with the piece arrangement that we used in the move copy aspect. So the product is associative between the different environments. That helps you save time because you don't have to worry about making sure your changes propagate. If we go now to our pattern view, and our pattern view is there, it's ready to be edited if you want to, and then our marker view. So very, very, very quickly, we have gone through our workflow. The last part of what we want to talk to you about is now putting together some documentation, and the documentation can be for a variety of reasons. You may do design reviews. You may outsource cutting. So this is a sample pack for vendors. It could be for assembly instructions. It could be for cut lists for costing or whatever it might be. But we built the drawing tool to be inside SolidWorks and work exactly the same way SolidWorks drawings are working. So the first part of the process is you select a template. We do support a variety of sizes, the same as SolidWorks if you have an A or B size or even a C, D, or E size a drawing standard. And once the template is loaded, it's just a matter of dragging your piece over from the piece list, and there you see Keith has already done that. It will come in with all the features and information that you've put on. We're going to go ahead and just put some more information on this to detail this drawing. So this is, we have 3 supported features. You can put tables, balloons, or callouts that are all automated. Keith has just put a table in here, so we're going to now put some balloons associated with this table. This is just a piece list. So you might do this, for example, for a cost if you want to send this information to your costing department or your vendors for putting together a cut list or things like that. And you can see it's very, very, very simple and straightforward to do. So material ID, we do support multiple materials, so if we're going to go ahead and change a material a little bit later and show you that you can update one environment and the other environments will be updated as well. And then let's just put some information, Keith, on the edges as well. Why don't you drag an edge table in there? So the SolidWorks drawing tools are very powerful, full-featured drawing tools. They don't support this kind of granularity in terms of edge features and notching and things like that. So we've built the additional utilities you'd need for soft goods in order to have your documentation be full-featured from a detail perspective without having to go through the process of recreating your drawings. I know that many organizations would recreate the perimeter geometry. You may use AutoCAD or even Adobe Illustrator we see quite often used, but this is a very quick way to do this, and of course you'd probably make your drawing a little bit cleaner than the one Keith is making right now, but I think Keith, we've made the point here. The last thing we want to do is we just want to show you some aspects of revision control. So you can see that we've got an edge table in here, and there's 5 or 6 actually different edges. So let's go back to our pattern view, Keith, and let's actually make some changes in our pattern. So let's add an additional edge in there, and let's change an edge type. So you can see when we do select an edge, if you want to make a change, the whole edge group is selected. That again is a big time saver. You don't have to worry about, do I have all the pieces? Once you've defined that edge group initially, it's very easy to go back. So we've taken that edge off. We're going to change the material now. And this might be if you, say for example, if you had a cheaper material or a different color, for example, that would be a different material type because then it would have to be cut separately. Okay, so you can see there is the changes we made to our seam allowance and the changes in yellow there are made to our material. And we forgot to get rid of the notch chain, so you can still see there's an artifact of the notch is still there. But suffice to say, if we got rid of the edge, we would get rid of the notch chain as well, and you know, you would be able to go ahead and edit those pieces again. So that's the big picture workflow. Keith, if you can just go back to our PowerPoint slide really quickly, and if you can go back to the agenda. So what we've done here is we've shown you the flattening process or initial pattern creation from a SolidWorks model. We've shown you the pattern engineering, and again, we've just given you an abbreviated version for the interest of showing you the bigger aspects of the workflow. We've shown nesting, how to get a production cut file from the nest, and then the drawing process. And if we go back, Keith, to the previous slide, our claim to you and our goal was to show you how you can go up to 90% faster going from CAD to cutter and CAD to document. So depending on what you're doing in your organization, we think that ExactFlat can help you achieve this. And if we just skip ahead, Keith, to the next slide, please. And in terms of how you would go from here, now we're going to open the floor to questions. I haven't forgotten about that. But in terms of how we go from here, it's a very simple next step in the process. If you tell us what area specifically you want to improve, so if you want to improve your design productivity in initial pattern creation, reduce the number of prototypes, assess manufacturing feasibility, get a more accurate cost more quickly, reduce time, design time for improve by 50%, 60, 70%, and you give us a file, what we'll do is we'll process that file for you with the folks at Allinex. We'll time the process and give you projected savings very quickly. It's something that we feel very confident we can do, and I would encourage all of you who are on the webinar today to certainly take us up on that. Now, Keith, if we can just go back to live view, please. Okay, so we have a couple of questions, and so the first question here is, can you export the flat pieces into a DXF format for our nesting software? And so the answer to that question is yes. What you saw there as the output is actually a DXF file, and the DXF file with all the supported layers and exported in such a way that it should be compatible with most of the cutters out in the marketplace, certainly all of the leading cutting table software. So that's not a problem. In fact, you don't have to use our nesting program if that is not what you want to do. You can save the SolidWorks part file in just 2D format, and then export that and put your features on in a separate package and go from there. So the answer to that question is yes. We do export the DXF format, and it is supported by the software. Okay, so the next question is, how do you handle tucks, buttons, gathers, and wrinkles? Okay, so the simple answer there is where areas are going to be, like for example, where you have, say, a piece of furniture with a flat back and then a rounded sort of front end, the flattening algorithm is going to tell you the areas of strain and sag. And so you'll be able to identify where your pleats and your gathers are going to be, and you can put notch markers on where you want the gathering to occur, or you could put notches in such a way that they can be spaced out so that you have a different feed rate from, say, a piece on the left-hand side versus a piece on the right-hand side. With respect to buttons, buttons would be using our markings tool. The markings tool would actually be a SolidWorks sketch entity that you literally mark on your pattern piece where the buttonhole is going to be, and the sort of wrinkling and so on that would be associated with putting the button in would be near the buttonhole. The process of modeling wrinkles is a challenging process in SolidWorks, and typically what we find, for example, in industries where gathering and wrinkling is a result of how the product is put together, is they don't model the wrinkles in. They just know that they're going to appear when they do manufacture them. Okay, so another question is, what if you don't have a 3D model? So if you don't have a 3D model, the program does support starting your process in 2D. So if you're using a 2D program today to sketch, you can use SolidWorks 2D sketching capabilities and go through the workflow in a very similar way. The only difference if you start in 2D is you have to manually associate one edge to the next edge. You don't get those levels of automation with associating the edges, because that was a byproduct of having the model in 3D. The other thing that you can consider if you don't have a 3D model is if you use laser scanners or if you use digitizers, either pro-based digitizer or point-based digitizers. A lot of our customers use those technologies to make the design process much, much, much faster. And depending on what type of products you make, if they're made out of components which are more or less standardized, you can create a library of different 3D designs and then take those 3D designs and dimension them. So you can have a piece that's, say, I don't know, 2 feet long versus a piece that's 28 inches long, and you can actually create dimensions on the part which would change the size and the geometry and then put it through the workflow. This is something that the AlignX folks can really help you with. Certainly if you're not using 3D today, to transition to 3D, there's a lot of very positive benefits to doing that. And also starting your workflow in 2D using SolidWorks is an option, and we do have customers doing both of those things. So if there's any other questions, we'd be happy to take them now. Otherwise, we're just coming up to the 1:30 time frame. If you have other additional questions, I would certainly encourage you to reach out to the folks at AlignX or the team at ExactFlat. And again, the very simple way, if you just go back one slide, Keith, the very simple way to get started is just tell us the priority area you want to improve. We can zero in on the aspects of how to improve that specific area. You give us a numeric target, whatever percentage improvement you want, and then a file, and we can go from there. And for the person who asked the question, what if you don't have a file? Well, we can certainly show you a workflow that starts in 2D, or we can use a file that we would have that would probably be similar to your industry. So, without any further delay then, I think, Keith, we can hand it back to Al and the team at AlignX to wrap up. But I'd like to thank everybody for taking your time today. This has been a demonstration of ExactFlat for SolidWorks. We're a gold certified partner. And this webinar has been brought to you by the team at AlignX as well as ExactFlat. I thank you very much for your time and your participation today.
All right. Thank you, Eden. Thank you, Keith. This is Al Switzer on behalf of everyone at AlignX. Thank you. And as I mentioned before, we will, your sales rep at AlignX will follow up with a phone call and discuss any potential next steps. Thanks, everyone.
Thank you.